Scene script. First up, we have Menelaus' theorem. Picture a triangle. We'll call it triangle ABC for simplicity. Now imagine lines passing through the vertices of the triangle, each intersecting an opposite side. Sounds complicated? Stay with me. These lines will intersect at a single point if and only if the product of the ratio of the lengths of the intersecting segments equals 1. Let's break it down. Take the points where these lines intersect the sides of the triangle. We'll call them points D, E, and F. So D is on side BC, E is on side AC, and F is on side AB. According to Menelaus' theorem, the product of the ratios of the lengths of the segments, AD, BE, and CF, to the lengths of the remaining parts of the sides thereon will always be equal to 1. Quite a mouthful, isn't it? But once you grasp it, the theorem becomes a powerful tool in your mathematical arsenal. Moving on, we come to Ptolemy's theorem. This theorem deals with an inscribed quadrilateral. An inscribed what? Picture a quadrilateral, a four-sided figure drawn inside a circle so that each of its corners touches the circle. According to Ptolemy's theorem, the product of the lengths of the diagonals of this quadrilateral equals the sum of the products of the lengths of its opposite sides. In simpler terms, if you multiply the lengths of the diagonals and add the products of the lengths of the opposite sides, you'll get the same number. This theorem is especially useful when dealing with cyclic quadrilaterals, where all four vertices lie on a circle. So, to summarize, Menelaus' theorem gives us a relationship between the lengths of segments drawn from the vertices of a triangle to points on the opposite sides. It tells us that the product of the ratios of these lengths equals 1. Ptolemy's theorem, on the other hand, shows us a relationship between the sides and diagonals of an inscribed quadrilateral. It reveals that the product of the diagonals equals the sum of the products of the opposite sides. Both these theorems, while seemingly complex, offer fascinating insights into the world of geometry and can be incredibly useful in unraveling some of its mysteries. So go ahead, dive into these theorems, explore them, and unlock a whole new dimension of mathematical understanding. The world of mathematics is full of surprises and wonders waiting for you to discover.